Though Franklin's experiment didn't immediately result in a full understanding of electricity, it was monumental in the history of science. His experiment provided evidence that lightning was a form of electrical discharge, and it led to further investigations into the nature of electricity. Franklin's experiment also resulted in several important inventions and ideas. Here's a more detailed account of Benjamin Franklin's famous kite experiment. The kite experiment, 1752. Benjamin Franklin is often remembered for his scientific experiments, and one of his most famous and risky experiments was his kite experiment in 1752. At the time, there was a lot of speculation about the nature of lightning, with many people believing that lightning was a mysterious, supernatural force. Franklin, however, had a bold idea. He suspected that lightning was actually a form of electricity, and he wanted to prove it. The setup. Franklin's idea was based on the theory that lightning and static electricity were related. In particular, he believed that lightning was just a huge discharge of electrical energy, similar to the sparks you could create with a static charge. To test this, Franklin decided to fly a kite during a thunderstorm to capture the electrical charge in the atmosphere. Here's what he did. The kite. He constructed a simple kite with a large silk sail and attached a metal key to the string. The kite was made of sturdy materials to withstand the storm. Franklin selected a day when there was a storm with dark clouds and lightning to give him the best chance of seeing a discharge. The experiment. Franklin flew the kite during the storm, hoping that the electrical charge from the storm would be transferred through the kite's string and into the metal key. The moment of discovery. As Franklin's kite rose into the stormy sky, the storm began to unleash lightning. The idea was that the electrical charge would travel up the wet kite string and into the metal key. Franklin attached a wire from the key to a Leyden jar, an early type of capacitor, to store the electricity. When lightning struck nearby, Franklin saw the key spark with electrical energy. The key carried the charge through the string, and Franklin was able to demonstrate that the storm clouds were indeed electrified. This moment was a critical turning point in the understanding of electricity. The aftermath and impact. Though Franklin's experiment didn't immediately result in a full understanding of electricity, it was monumental in the history of science. His experiment provided evidence that lightning was a form of electrical discharge, and it led to further investigations into the nature of electricity. Franklin's experiment also resulted in several important inventions and ideas. The lightning rod. Franklin realized that the electrical charge in the air could be dangerous for buildings. He invented the lightning rod, which helped protect buildings from lightning strikes by safely channeling the electricity into the ground. The term battery. Franklin also coined the term battery to describe the Leyden jars that could store electrical energy. A risky experiment. While Franklin's experiment is often romanticized, it's important to remember that it was extremely dangerous. Franklin was flying a kite in the middle of a thunderstorm, something that today we'd consider highly reckless. He was lucky not to be struck by lightning, and some believe the story might have been exaggerated or romanticized over time. But even if the details are somewhat embellished, the core of the experiment is a pivotal moment in science. Legacy. Franklin's kite experiment remains one of the most iconic scientific experiments in history. It not only proved that lightning is a form of electricity, but also helped lay the groundwork for the study of electrical science in the centuries that followed. His work directly influenced the development of electrical technologies that would power the modern world. It's one of those stories that blends curiosity, courage, and genius. And it's a testament to how scientific inquiry often requires taking bold steps into the unknown.
Welcome to IT Electro CE Certainly. Let's dive deeper into the kite experiment and its significance in history. Background context. Before Franklin's kite experiment, electricity was a mysterious force that intrigued many, but it wasn't well understood. Some scientists, like William Gilbert, had explored the idea of electricity in the late 16th century, but it was still seen more as a novelty or curiosity. In the 18th century, scientists like Stephen Gray and Charles-François Dufay began to make connections between electricity and natural phenomena, but the idea of lightning being an electrical discharge was not widely accepted. Benjamin Franklin, a man of wide-ranging interests and a scientific mind, wanted to prove that lightning and static electricity were the same thing. He was particularly interested in investigating whether the electricity that could be produced by rubbing materials together, static electricity, could be the same type of force that created lightning. To test this theory, Franklin had the idea to conduct an experiment during a thunderstorm. Why Franklin chose a kite? Franklin needed a way to capture the electricity in the air during a storm. The idea of using a kite was based on his understanding of how electricity moves through conductors. The kite's long string would allow it to fly high into the atmosphere where electrical charge could build up. The wet string would act as a conductor, transmitting the electrical charge from the storm clouds down to Franklin's hands. Building the kite. Franklin needed to design a kite that would survive the storm and conduct the electricity properly. The kite itself was a simple design. Frame. The kite frame was made of flexible wood, often described as lightweight and durable. Franklin used a large silk material for the kite's sail. Silk is a good conductor of electricity, which made it useful in ensuring the kite could carry the charge. String. The string was crucial to the experiment. Franklin used a string made of silk, which was also a good conductor when wet, though in some versions of the story, it was said the string was a mixture of silk and hemp. Key. A metal key was attached to the end of the kite string. Franklin believed that when the kite caught the electrical charge, the key would conduct the electricity down the string and allow it to be measured. The key would act as a kind of receptor to detect the charge. Leyden jar. Franklin used a Leyden jar, a type of primitive capacitor that could store electrical charge. A metal wire connected from the key to the Leyden jar, and this would capture any electrical energy that was transferred down the kite string. The experiment. The day of the experiment. Franklin's experiment took place in 1752, during a thunderstorm. This was the critical time Franklin was waiting for. A storm with heavy clouds and lightning provided the perfect conditions to test his hypothesis. Flying the kite. Franklin flew the kite into the storm and hoped the charged particles in the atmosphere would travel up the wet string. As lightning flashed nearby, the electrical charge moved through the string and into the metal key. The spark. The key, connected to the Leyden jar, sparked when Franklin observed the presence of electrical charge. It was a significant moment, as it confirmed that the storm clouds contained electrical energy. The key was essentially acting as a conduit, carrying the electrical discharge from the kite to Franklin. The Leyden jar. The Leyden jar was used to collect the energy. As the charge built up, Franklin noticed the jar started to accumulate electrical energy from the lightning strike. This demonstrated that the charge in the storm was the same type of electricity that could be stored in a capacitor. The risks. The experiment was incredibly risky. Franklin was flying a kite in a thunderstorm, and the key was in direct contact with the storm. If the lightning had struck the key directly, there was a real possibility that Franklin could have been electrocuted. In fact, Franklin's experiment may have been even more dangerous than many accounts suggest. He was essentially playing with nature's most powerful electrical force. Today, scientists and electricians would never dream of conducting an experiment like this. Some versions of the story suggest that Franklin did not fly the kite himself, but instead sent his son, William Franklin, up with the kite. However, historical accounts are unclear on this point, and it's generally believed that Franklin himself was present during the experiment. The results and impact proof of lightning as electricity. Franklin's primary goal was to prove that lightning was a form of electricity. The sparks from the key and the transfer of energy into the Leyden jar confirmed that lightning and static electricity were part of the same phenomenon. This was a monumental discovery,